So now we're gonna go back to kind of Python programming and stuff. We took a small detour to do like data related stuff in Python. So we covered NumPy, pandas, data visualization with Seaborn and Matplotlib and stuff, and that's great. But yeah, now we'll go back to programming in Python, and specifically, we'll look at the object-oriented system in Python, which this is my opinion, but but the object-oriented programming system in Python, I think, is like one of the best, if not the best, like object-oriented system. Okay, so uh, like R has object-oriented programming, and a bunch of languages have object-oriented programming, but Python does it really well. Let me get everybody's attention here. Okay. All right. Okay. So we'll just kind of work through this by example, and so we have so we can start defining certain, I guess, object types. Okay. So we've seen different object types, and we call these like data types and data structures. We have like lists and dictionaries. Those are all kind of built in, and then we've had ones that were kind of brought in when we brought in packages like the pandas data frame, the NumPy array. Those are also kind of different object types, and you might find a use where you want to create your own class and your own object type. Now, to be honest, in my day-to-day kind of coding and interaction with data and things like that, I don't find myself needing to define my own classes very often. It's kind of a rare circumstance. However, pretty much all of the packages, I don't know about all of the packages, but a lot of the packages out there, most of the packages out there, use the object-oriented system, and create objects, and you use objects within this system, and so it's useful to understand how the thing works. Okay, sometimes you'll read other people's scripts, other people's code, and they will have created their own classes. And if you're not familiar with the object-oriented system, then you'll have difficulty reading their scripts and understanding what's happening. So even if I don't create, and I don't know how often you'll create your own classes outside of like homework assignments and stuff, I think it's still very useful to learn how these things work. Okay, so anyway, I'm gonna just start by just showing you how to create your own kind of class. Okay, and so we're gonna create a class called point. Let me zoom in a little bit and make it easier to read. Okay, and so we're gonna say, like, let's say we want to represent a point on the Cartesian coordinate plane. Okay, and so points, we need an x coordinate and a y coordinate. I mean, you could have other coordinate systems, right? Like polar coordinates and stuff. But here we'll just go x coordinate, y coordinate. And as far as like, okay, well, how do we store this information? We could just have two separate variables. You can have an x variable and a y variable. You can create a list, or you can create a tuple, and you can say, all right, the first element is going to be x, the second element is going to be y. That's probably like the most straightforward way. And there's actually something called a names tuple where you can do that. And then there we can also go the third route, which is a little bit overkill, but useful as far as teaching goes. And we're going to create our own new object class called point. Okay, and so creating a new type is going to be more complicated, but I think it'll be useful. So let me go ahead and do this. We'll restart. Well, let's see. Okay. Yeah, let me restart everything. Okay, so here I'm going to define a new class, and this is just done by using the keyword class, and then you give the name of the class. The convention is you use a capital letter for when you define a class. Okay, so and this again, Python's not gonna give you an error if you don't use a capital letter. But as far as like making your own code easier to read, having proper punctuation, having proper capitalization in like text messages and stuff makes it easier to read someone's text message versus someone who just writes all lowercase and spaces and no punctuation at all, right? And similarly, if you follow kind of the convention rules, it makes it easier to read. So here I'm defining a class point, and there's actually nothing inside the definition of this class. All I've done is I've put in what we call a document string, okay? And this document string, or the doc string header, you just kind of put in the quote here, and this is kind of like if you ask for help on like what is a point, it'll give you this, and it's just usually just a thing right here. So if you so now that I've created this class, I can say what is it, and if I print it out, Python tells me that this is a class object. Okay, it is a new class called point. The full name of this is going to be double_main, okay, dot point, and this is to indicate that it exists in kind of the, I guess the level, the environment that it's in is double_main, which is kind of the top level thing. Okay, we create, once you've defined the class, okay, you create objects or instances of that class by calling the class almost like a function. Okay, so you write point and then you put parentheses, and that's kind of like the way we call a function. And then this is going to create an instance. Okay, and so you can think of the class as a factory, and then you push the button, and then the factory produces something out of the kind of the conveyor belt. And so now you have an instance of the class. And so if we ask, what is blank? Okay, blank is going to be an instance of class point. Okay, and so it's going to say this is double_main dot point, and it gives you the memory address of that thing. Okay, and so right now we just have a new class called point, and it really has nothing in it. Okay, now that we have an instance of it, we can start giving this instance attributes. Okay, so I'm going to give it an attribute called .x, blank.x, and then I've got blank.y. So this is the instance. So I'm not using point.x. Blank is the instance of the point. Okay, and we're going to assign 3.0 to x and 4.0 to y, and that's it. It just has defined these new attributes, and this is, it's done like this. It's just done on the fly. Okay, there's this x and y is not part of the definition of the class or anything at this point. You can just kind of, if you have an object, you can just add arbitrary attributes and things like that. And the syntax is basically the object instance, and then whatever attribute you want. And then if you want to retrieve that value, you can always ask, hey, what is blank.y? It's going to come back and say it's 4. You can kind of take it, you can say blank.x is equal to x, and this x is unrelated to this x. Okay, this just takes the value. Okay, so x right now is 3.0. If I modify blank.x to be, say, 5, okay, x here is still going to be 3.0. Okay, this x that we created back here just happens to have the same name as x, and it's not tied or pointing or linked to the attribute blank.x or anything like that. Okay, so anyway, here I'm going to take the values, the attributes inside blank.x, and I'm going to use a format string. Okay, so with a format string, I can kind of write a string with placeholders, and we saw this in place. I'm going to just say first placeholder, second placeholder, general notation, and then we'll fill in the first placeholder with the .x and the second placeholder with the .y, and we'll do that. It's much too warm. Okay, so we have that, and so now that I've changed the value of x to 5 and so forth, and I print it out, I get the string 5, 4. Okay. If I want, just so I don't have to keep writing this like this, I can write a function, and this function will be print point, and this function will take in some argument p. In this case, p is going to be a point object, and then what this function will do is it's going to print out the point by printing out the string, taking the x attribute of p and the y attribute of p. Okay, so now that I have a function, I can just call it print point blank, and then it prints it out, and we get 5, 4. Okay, so that is that's just kind of like the introduction to classes, and here we've really done nothing so far other than just use the keyword class and then create an instance and then just assign arbitrary attributes. Okay, but let's just kind of take this and kind of keep building on it, and with objects, you can have objects that use other objects, right? So it's kind of like a car is built out of a whole bunch of different parts and pieces, and each of those things might be built out of different parts and pieces. And so similarly, you can kind of construct, more and more complicated things by using other objects here. Okay, so what we're going to do here is we're going to create another class. This class is going to be called rectangle, and this rectangle class is going to, the way we're going to do it is we're going to have the width of a rectangle, the height of a rectangle, and then we will specify the corner, and we'll do like, I think the lower left corner. Okay, so we'll put a point as the location of the corner, and then I'll have the width of the rectangle and then the height of the rectangle. That will define some rectangle that exists in the coordinate space. Okay, so again, right now we have just an empty class definition. There's actually nothing inside of here, but we're going to create an instance of it. We'll call this box. Okay, and then for the box, we'll give it a width, we'll give it a height, and then we will give it, I'm going to define a attribute called corner, and the corner is going to be an instance of the point object. Okay, and then so now that this is a point object, I'm going to do box.corner.x and box.corner.y, and we'll set it to be the origin. Okay, and so here we're just defining a rectangle, and we've just kind of manually added all of these attributes here. Okay, so what we might want to do now is we might want to have a function that, as the argument, it takes in the rectangle and it will return the location of the center of the rectangle. Okay, so we're going to do find the center of the rectangle. So, so right now we have the corner, and then we've got the x attribute, and we've got the y attribute, or I'm sorry, this is not x, this is width, and we have height. Okay, so we can just imagine that being our rectangle, and then now we want to have some function that will return the center. So what is the center? The center, the location of the center is going to be basically the corner x plus basically 1/2 of the width and then you're going to have corner y plus 1/2 of the height. Okay, and so this function, find center, is going to take in a rectangle. Within this function, we're going to define a new instance of point, and we're going to say the x attribute of the point is going to be the corner x plus 1/2 of the width, and then the corner y plus 1/2 the height. Okay, we'll assign those to be attributes of this new point P, and then we will return P itself. Okay, so if we ask what is box, box is an instance of a rectangle. Right now we can't see anything, so we can just say box.corner, which right now is just an instance of a point. And so we have to ask something like box.corner x is currently at 0, and if we do box.corner y, it'll also be 0. I could say, all right, find the center of the box. Okay, right now center is also an instance of the point itself. We can say, all right, where is print that point? We have the function called print point, and it's going to say, okay, the center is located at 50, 100, because the box width and the box height, if you recall, are 100 and 200. Objects themselves are mutable, much like lists and any other dictionaries and things like that. Sorry. So here I can say, all right, here is box width, it's 100. I could take box width, add 50 to it. I could take box height, add 100 to it. Okay, and so now my box width is going to be 150. Okay, my box height's now going to be 300, and things like that. And so if I wanted to, I could write a function that will say grow the rectangle. Okay, and so this is just like, it's going to take in the rectangle. I provide extra arguments, and we're going to have the rectangle grow by the delta width, and we'll have the height grow by delta height. Okay, or d width, d height. So currently my width and height is 150 and 300, and I could say, hey, grow it by another 50 and 100, and so then we'll get the box width will be 200, the box height will be 400, right? So we can start growing these things like that. Okay, so when we do something like this, all right, it just notice that because the argument for the rectangle inside grow rectangle is called rect, while the function is running, rect is going to refer to the object box. Okay, so inside the function, the argument rect becomes an alias for box when we call the function on box. Okay. Okay. So I wrote, the fact that objects are mutable can sometimes make the code difficult to read, especially when you have functions that modify objects without necessarily reporting or printing anything to the screen. So for example, here is, I'm going to just create a new instance of point. We're going to give this point an x and a y of 3 and 4. I'm going to call copy, and then we'll create a copy of the point. Okay, so we're going to copy P1, and this will be P2. So P1 and P2 are right now 3 and 4. I can say, are they equivalent in value? Or are they equal to each other? They're not, because one's a copy of another. If we say is P1 is P2, they are not the same. And actually, our test for equality, we don't actually have a full test for equality for P1 and P2 just yet. Okay, for points. Okay, so right now the equals is just asking, are they the same, and they're not. Okay, even if the values inside 3 and 4 are the same, right now equals doesn't understand that the contents inside are the same. Okay, P1 is an instance of the point. Its memory address is this. P2 is an instance of the point, and its memory address is a little bit different. Okay, or it's not just a little bit different. It's just different, right? Even though you have that. Okay, so we talked about shallow copies and deep copies before. And so a shallow copy copies the object. And if that object references other objects, it will copy the references to those other objects. But deep copies will create if the object has references to other objects, it will create copies of those other objects as well. So if you remember box, we have that. Box.corner is a point at this memory address, okay? And box.corner.x and box.corner.y is currently 0, 0. Okay, so this corner, the current corner of box is here. I'm going to make a shallow copy of box. Okay, so we're going to have box 2. This is a copy of box. Box 2 is box 2 the same as box? It's not, okay? Because this is a copy, this is a different object from here, okay? However, is the corner of box 2 the same as the corner of box? It is for a shallow copy, okay? So if I were to kind of modify this corner of box to somewhere else, all right, it would modify the corner of both box and box 2, okay? So box 2's corner and box 1 corner is the same point. And I can verify, I could say, hey, what is box 2? We see the address location. What is the address of that? And we could see this thing has the exact same address, right? So the corner attribute in box is a point object, and both box and box 2's corner attribute refer to that exact same point, okay? So if I say box.corner.x, we're going to change it from 0 to 1, okay? Box.corner.x value is now 1. As expected, box 2 corner, even though I never mentioned box 2, its x attribute is now 1, okay? Because we are modifying the exact same object. We are both box 1 and box 2, or just box and box 2, are looking at the same thing. They have the same object, okay? However, if I change box height is 400, box 2 height is 400. If I change box's height to 200, box height is now 200, but box 2 height, because box 2 is a copy of box, it's not going to be affected. So box 2 height remains 400, okay? It's not modified, okay? On the other hand, I can make a deep copy, okay? I'm going to create box 3. Box 3 is going to be a deep copy. And so currently box height is 200. I think box width is 200. So we could say, all right, let's make a deep copy of box. Is box 3 box? That's is not true. Okay, it's false. Okay, and then what about the corner of box 3? Because it's a deep copy, this corner and this corner, they are different objects. Okay, so it's when it creates a copy, it's going to have like the same start off with the same values, but they're different objects. Okay, so it's kind of like if you and your roommate share the same textbook. Okay, that would be like a shallow copy where if somebody writes notes in the textbook, the other person, your roommate, will also see the same notes. Okay, however, if you and your roommate buy separate copies of the book, that would be like a deep copy. Okay, your textbook and their textbook are different. You write notes in your textbook, they're not going to suddenly see notes in their textbook. Okay, so that's like the difference between shallow copy and deep copy there. Okay, here, let me give you view quiz answer. Week 7, Monday. Oh, it's not up there. Oh, okay. Let me publish. It's up now, right? Okay. Okay, first answer is C. C as in cat. C as in cat is our first answer. All right. Let's write some functions, and then we'll also start to create methods and things like that, okay? So here I'm going to create a new object, class, a new class called time, okay? And this is going to be used to kind of represent the time of the day. It's just an arbitrary thing, okay? Again, we haven't actually defined anything, but what we'll do is we'll create a new instance of time, and then I'm going to set the hour, minute, second. Okay, so we're going to say 11:59 and 30 seconds. And then I'm going to create a function that's going to take the hour, minute, and second and paste them together so it looks like a digital clock, right? So I'll call print time, and then we get 11:59:30. All right. So we have that. We can create some additional functions and things like that. Now, there's a few different ways to kind of think about stuff, and you have prototype and patch, which is probably how a lot of us code, which we start off with something simple, and then we say, all right, I want to add a feature, and then so we add some additional code. And then as we add features, we realize like, this has created a problem, so I need to write more code to fix that problem. And then, your solution creates, a different problem. And so you just kind of keep at it. It's fine. It's a very viable strategy, and that's often how we get things going in the first place. At some point, though, you might want to, what we would say is refactor, where you just kind of rethink everything. Now that you have like the kind of the full structure and you understand like, okay, this is everything, it's doing everything we want it to do. Let's try rewriting the code. But anyway, we'll just kind of start off with this idea of prototype and patch, and then we'll kind of increment it. So let's say we want to take 2 times and add them together, okay? So we could say we've got time 1 and time 2, and then what we're going to do is we want to return the sum of our 2 times. So sum is going to be a new time instance, and then we'll take the hours of time 1 and time 2, add them together, take the minutes of time 1 and time 2, add them together, take the seconds of time 1 and time 2, and add them together. So that's a simple function. And then so we'll try this out, and we'll do start is going to be 9:45. Duration will be 1 hour and 35 minutes. And then we could try adding them together, and let's print out the result, okay? So if we start at 9:45 and we run for 1 hour 35, what are we going to get? It returns, and it says you get 1080, which it did exactly what we asked it to do. 9 plus 1 is 10, 45 plus 35 is 80. And we realized like, okay, 1080, that's not correct. We got to rewrite it to be 1120, right? So, if it goes past 60, we've got to fix this up. So we'll take our previous function, add time, and we'll change how it works. And we'll say, okay, let's add the hours, minutes, and seconds together. And if the seconds are over 60, take the number of seconds and subtract 60 from it and add 1 to the minutes. And then now look at the minutes, and if the minutes are over 60, subtract 60 from it and add 1 to the hours. Okay, so let's try this again. All right, so I have start and duration is still 9:45 and 1 hour 35. And I'll try adding them together. And ta-da, it works, okay? Now we have 11:20, so we feel like, okay, that's good, okay? What if we wanted to have a function that modifies the function, all right? So this is a modifier, okay? So what this does is it takes an object, you provide an argument, and then it changes the object itself. So here I'm going to say, hey, let's do increment time, and we'll increment it by a certain number of seconds, okay? And then we'll do these same kind of things where if the number of seconds is over 60 or if the number of minutes is over 60, fix the problem. So, so we'll try this. And so here, my test time will start off at 9:45. And then I could say, all right, let's try incrementing 90 seconds. So what's 90 seconds after 9:45? So let me when you call increment, it actually doesn't, it runs, but it doesn't look like it's done anything. And that's because it's just modified it. But if I say, hey, what is time now? It has correctly modified to be 1 minute and 30 seconds, 90 seconds after 9:45. So we get 9:46 and 30 seconds. Okay, so that worked. Okay, what if I add 185 seconds to test time? So that's what, 3 minutes and 5 seconds after this? And if I run this, now it's saying it's 9:47 and 155 seconds. And we realize, okay, this doesn't quite work because as far as my function definition goes, we just say if it's over 60, subtract 60, but I had like 185, right? So so this is kind of the issue here. What we're going to do is, if we say, okay, let's say I've added a big number of seconds, like 180 seconds, okay, 185 seconds, what I'm going to do is I'm going to do modular division, okay, div mod, and we'll do seconds divided by 60, and that will return basically a whole number part, 3 minutes, and the remainder, 5 seconds, okay? And then just in case I give a really big number, if that number is over 60, then we'll div mod the minutes. In our case, we'll get 0 hours and 3 minutes, but we'll have that. We'll have the minutes and seconds, and then I can take my current time in seconds, add the number of seconds I have, the current time in minutes, add the minutes, add the hours, and then if any of those are over 60, then we'll subtract 60 and add 1, and so on and so forth. Okay, so let's try this again. So we've got 9:45 as our start time. We'll add 185 seconds. Okay, and that seems to have worked correctly. 185 is 3 minutes and 5 seconds. 3 minutes and 5 seconds after 9:45 is 9:48 and 5 seconds. Great. Okay, what if I add 4,800 seconds, which is 1 hour and 20? Okay, so we'll add 1 hour and 20 to 9:48:05, and yeah, that works. 11:08:05. So far so good. Okay. This is a modifier. This is in contrast to a pure function. A pure function takes arguments in and returns a new object. And you'll notice the modifier, when it runs, it doesn't actually return anything. It just modifies a thing. Okay? Modifiers are convenient, but they can become difficult to debug because, or they can contribute to difficulty in debugging because things can change, and you have to know exactly which of your functions are modifiers and where the change actually happened. Okay. All right, let me give you your second answer, which is B. B as in bear. B as in bear. Okay, so this kind of prototype and patch, you know, it's a system that can work just fine as far as, like, you know, we tried something, we run a test case, we realize, okay, there's a problem, so let's fix it, and then we run more test cases, we run into more problems, and we fix those things, okay? Designed development and this planning idea is you try to think of, like, all of these different kind of scenarios and situations that you'll encounter from the start, and you try to think of an efficient system that can address this, okay? This is generally going to result in more elegant solutions, but it's also, like, much harder to plan in this way, right? Because you really have to think about all of the different scenarios and things like that, okay? So one way we can apply that kind of idea to the time situation is we could say, all right, what if we took our starting time and our duration or whatever, and what if we just turned everything into the number of seconds after that have passed since midnight or some arbitrary point in time, okay? And then we'll convert everything to seconds, and then we'll add the number of seconds together, and then we'll convert them back, okay? So this is going to require two functions. A function to convert the time into the number of seconds, and then a function to convert the number of seconds back into time. Okay, so we'll take time to int, and what we're going to do is we're going to figure out the total number of minutes by taking the number of hours, multiply it by 60 and add the minutes, then take the current number of minutes, multiply that by 60 and add the number of seconds. That will return the total number of seconds. Okay, and then to go back from the number of seconds back to a time, we'll div mod the seconds to get minutes and seconds, and then we'll take those minutes, we'll div mod the minutes to get the hours and minutes, and then once we have that, and we assign basically the seconds to time.second, and once we div mod the minutes, we'll assign that to time.hour and time.minute, and then we'll return that time object. Okay, so just to kind of test this out, I'll start off with 9:45. We will convert it to an integer, 35,100 seconds after midnight. And we could say, okay, what if we convert 35,100 back into a time, and then we print that out? We should get 9:45 back, and we do. Okay, so that feels okay. And then, so now, the adding time function becomes a lot more elegant, right? Because I can say, all right, take 2 times, t1 and t2, convert both of those into the number of seconds using the time to int function, and then I add those together to get the total number of seconds, and then we'll go take that seconds and convert back to a time, int to time. Okay, so my start is going to be 9:45, my duration will be 1:35, and I can say, okay, if we do not start at 9:45, it runs for 1:35. When do we finish? And it finishes at 11:20. Okay, so this is where we'll use. This is what we'll use. So we have these 3 functions. We've got time to int, int to time, and then we have a way to add our time together. Okay, and so far all we're doing is we're just creating functions, and within our functions we're taking in objects, and then we're modifying those objects along the way. Okay, so now that we have these functions, let's talk about methods. Okay, methods are functions, okay, but those functions are associated with a class. Okay, and basically methods are exactly the same as a function. Okay, but the key difference is that the definition of the method exists inside the class definition. Okay, and then to call a method, you invoke it using a slightly different syntax. You basically call it from the object itself. Okay, so right now, this is kind of what we have, and I just have it rewritten here. But basically, my definition of the time class has no methods inside of it right now. There's nothing inside class time. It basically just has a document string, which is not going to do anything. Okay, and then right now, my function to print the time, I have a separate function called print time, and this is going takes this document this string, this format string, and then it formats it, right? And that's what we get. Okay, and so this is how we use it. We define the thing and we put that in. Okay, so to make a method, all I'm going to do is I'm basically going to just take this function and move it inside the definition of class. Okay, of the class definition. Basically, that's all I'm going to do. All I'm doing is I'm just going to copy this thing, and all I've done is just copy and paste this. Okay, so I've got class time. I could put the document string in there, but I didn't. Okay, and all I did is I just copied and pasted that function definition in here. Okay, and so now I'm going to define a new instance of time. Okay, and we're going to give it 9:45. Now, so this is where things can get confusing. Is that whenever you change the definition of the class, you have to create new, this change of definition only affects new instances of the class, okay? Anything that was created under the old definition still exists under the old definition. So, you know, every year Honda releases a new model of the Civic, but your car that you bought 3 years ago doesn't suddenly get updated when they release their new model, right? That'd be nice, but that doesn't happen, okay? And so here, if we want a new instance of time that uses the new definition, I have to create a new instance, and here I'm going to still define start hour minute second, or hour minute second, and we have that, okay? Okay, and then so now that I have this to invoke the method, okay, there's two ways. One is you can call it using its full name, okay, and that would be time, capital T time, dot print time, because this is the function defined inside time, and then you give it the object, okay? Nobody uses this, okay? But this is one way to do it. This is like calling by the full name of the thing, okay? Almost everybody uses this thing where you have the object itself. The object itself is called start. That's this instance of this. And then we call the method print time from that object, okay? And when we do that, then it prints it out as 9:45, okay? So we just invoke it using print time using the dot notation, okay? So now we have that start.print time. And basically all I did was I just copied and pasted the definition that we had that existed outside of the function into class time, okay? And you'll notice when I called print time, I didn't have to put, okay, so over here, I put in the object start, okay? But over here, I didn't, right? I didn't put in any object inside the argument. And that is implied because we're calling start.print time. So it knows this thing is just referring to itself, okay? And so the convention is that when you write a method, okay, the argument that goes inside of there is going to be called self, okay? So back here, I just copied and pasted, and so we had it called time, and we had time.hour, time.minute, time.second. But by convention, we don't use any argument names other than self as far as the first argument goes. So here I'm going to kind of just expand my definition of class time, and all I've done is just replaced the argument in here with self. Okay, so I got define print time, and self is going to be self.hours, self.minute, self.second, and we're going to print that out. And then I'm going to also have time to int in order to convert a time into the number of seconds, and we'll use basically that same exact definition as before, where we're going to take the number of hours and minutes, multiply them by 60, add them together to return the total number of seconds here. Okay, so this is going to be the definition of class time. All right, is that all right? So now I've got, I have to redefine my object again because I have a new definition of time. So I got 9:45. I'm going to call the method print time on 9:45. 9:45 gives me this. And then I have a method time to int, and when we want to convert 9:45 into the number of seconds after midnight, we get 35,100, okay? We still have this function, int to time, that goes from like 35,100 back into a time object, okay? This can't be invoked as a method because it's applied to an integer, right? So the argument of this is the integer 35,100, not a time class object or something. So this still kind of has to exist outside of the class definition. Okay. I'm going to add another function here. So these are all functions that we've created, and we'll say, all right, we've got print time, we've got time to int. That's going to be part of it. I'm going to add another method to it, and this will be the increment. Okay, and in this one, we're gonna increment itself with a certain number of seconds, and so we're gonna take seconds, take self.time to int to convert it to the number of seconds. We'll add it to 2 seconds here, and then this thing is going to return a new value of the time after we've converted the seconds into the time there. Okay, so again, here's 9:45. Start. We're going to print it out 9:45. I'm going to increment it 1,337 seconds, which I think is 22 minutes and 13 seconds or something, or 17 seconds. And so indeed, that works. If I do start.increment at 1337, this is going to define a new instance of time, and that's going to be end.printtime. That will be 10:07. Start is still 9:45, okay? And that's what we have there. Okay, let me do one more, all right? And we'll say, okay, sometimes we run into errors, okay? And so here, notice that when I called increment, this 1337, where did it get passed? It got passed in to the argument for seconds here. It didn't get passed in as self. Self is always going to get passed in as the first argument. So if I try to call start.increment and I give it 2 numbers, 1337 and 460, I get this error, okay? It says increment, time.increment takes 2 positional arguments, but 3 were given. And you might be like, what? I only have 2 arguments in here, okay? But self is always one of the arguments, so it's going to see it as self 1337 460, and so it's going to see that as 3 arguments. Okay, so that's going to be the error that you get. Okay, we will stop here for now, and then we'll continue this on. There's a lot in this object-oriented thing, so we'll pick up from here on Wednesday. Okay. All right, let me give you your last view quiz answer, which is the letter A. A as an apple. A as an apple will be your third answer. Okay, that's it. We'll see you guys later.